Hey guys, welcome to day 59 of Codeforces Everyday until GM. Yesterday, a bit of a short video. Today, back at it with longer videos. Let's start off with a 1200 problem. Dora and search. This seems to be a two-pointer problem. Alright, as you know, the girl Dora is always looking for something. This time she was given a permutation and she wants to find such a subsegment of it that none of the elements at its ends is either minimum or maximum of the entire subsegment. More formally, you are asked to find the numbers L and R such that AL does not equal to the min of AL plus 1, AL does not equal to the max of this, and then AR does not equal to min, AR does not, A permutation of length n is an array consisting. Okay, I know what a permutation is. Find such subsegment. Okay, so let's just take in our input first. T equals input for I in range T. In equals input. A equals list map int input split. Alright. Okay, so what's going on? She's given a permutation, find such a subsegment of it that none of its elements at its ends is either the minimum or maximum of the entire subsegment. Formally, you are asked to find the numbers L and R such that AL does not equal to. Okay, you want to find a subsegment such that AL is not the minimum and AL is not the maximum, and AR is not the minimum and AR is not the maximum. Okay. In the first and fourth test case, we showed that there are no desired subsegments. In the second test case, 1 and 4 satisfies all the conditions because max 1, 2, 3, 4 min is 1. As we can see, the conditions are not met. So we found a subsegment, which is the entire array, such that 2 is not the min and 3 is not the max. Okay. So for this third case, two, 6. Okay. So don't we just find the min and max and then we track the ends? I feel like this is pretty simple, no? Min A equals min A. Max A equals max A. L equals, okay, LR equals 0 and minus 1, while L less than R. If A 0, is if not in a max A, print or L plus equals 1. If not, just copy this. Make this R, make this R minus equals 1. We can track like L found, R found, equals false, false. L found, true, R found, true. If L found and R found, break, print LR. Uh-oh. Okay. 1, 2, 3. Oh, we need to check for impossible. It's impossible when okay, so we move this here. Wait, why can't it be this? Such that AL does not equal the minimum of it. Okay, this isn't exactly right then. It's not the minimum of the whole array, it's the minimum of the subarray, right? It's a permutation, so we know what numbers are in it. So it's actually min A max A. We don't even need to run an operation. We just know by default the min is 1, max is 7, max is in. We can keep this. Now, every time we remove a number, so we know the min and max, so why not do this? Let's do this. instead of just checking these cases, what can we check? We can check if it's equal to the number, if AL is equal to min A or max A. We need to do L plus, and then we need to do either min A plus or max A plus, or minus minus. Same for R. Min A L plus equals 1, min A plus equals 1. If AL equals max A, max A minus equals 1. Max A minus equals 1. So it's something like this. No, it's not going to work because I need to add a bound condition. Okay, I just want to see how it works with something that works first. Logic's something wrong somewhere. 2143. Start here. Start here. R min is equal to 1. Max equal to 4. Okay, let's check left. good. Check right is good. So therefore, return LNR. Okay. Now what if we had something that takes a little more tries? 2, 6, 1, 3, 2, 4, 6, 5, 7. Start min max. Check left, it's min, so we move. Min plus 1 is 2. Check right, it's max, so we move. Min minus 1 is 5. Check left, it's good. Check right, it's good. So we return left and right. Now if we have impossible case, 1, 2, 3, min, max. Check left, no good, move, plus 1. Check right, no good, move, cross, so print everyone, continue. Okay, so it's just our logic here is wrong somehow. Okay, so what do we, first step, check left. If AL equals min A. So what was wrong with this? If AL equals min A, increment L, increment min A. If AL is max A, decrement. AR is min A. Increment. What if we increment and it becomes the max? That's a case, right? Like 1, 3, 2, or like I don't know, 1. But like it shouldn't happen, right? What's exactly happening here? Okay, we need to do if L is not L found, everyone name this fount. I don't know why I always replace D's with T's. Kind of annoying. L if else are found. If L found, A R found. Break. Why does it run forever? Like, where actually is it catching? And why does it take a while to... Okay, so first things first, what it should do is we should be able to iterate through the entire array like this. So L plus equals 1, R minus equals 1, print A, L, A, R. Two, three, 1, 4, -1. Okay, now if A, L equal to min A, we do this. If A, R true max A, we do this. And then we do min A plus equals 1, max A minus equals 1. Why does this run forever? It's because okay, 2, 3, 2, 3, 0, 3. Does this make sense? Two, three, 1, 4. Oh, 3. Okay, so by default we need to do this. Now I need to check this case too. Okay, I'm starting to think the earlier thing didn't work because I didn't set it equal to true, which would be really shitty, and that means I was debugging for nothing, rewriting code for nothing. But it is what it is, and I think what I'm doing now is working to some degree. So I'm gonna keep doing it and delete all this. It might be the exact same thing as what I wrote earlier. Okay, so if I delete this, expected output is 1, 4. This is still wrong. 1, 4, 2, 6, 1, 6. So this is the case where after you move it, it becomes the minimum. So I feel like I need to move this to the end or something. Like I can't check it first because moving R might break stuff. Moving R, it means we need to check one more L. So actually, I don't know if this works, but I have this idea of what if I just put it in the middle. So that didn't work. So if we look for L first, say we find it, because in this case it does, right? Alright, let's do 2, 3, 6, 5, 4, 1. Min, max, the equals 1, 6. Start here. Found, so this stays. This is not found, so this moves. Min plus equals 1. Left now equals min. So we have to set L found equals false. Here. Okay, that didn't fix it. But it's no longer min. So L found is false, and we move over. And min is now 3. Okay, now we go through max. This is fine. Now we go through min again. 3, 3, false, so we move one more. This is now 4. Check right. It's 4. That's no good, so we move it and update min to 5. Now that's no good, and we cross over and it breaks. So, okay, I should isolate this test case. Now I should figure out what exactly it's doing. So I want to print out L found L and R or and max or min A max A. R found R. Okay. So we're found. Okay, let's also print A L R. Found. Wait a minute. R. Is this Y? We needed to do R plus 1? I don't think so. I think we're just viewing it. Right. True. L. Wait, I don't care about L. I care about AL. AR. True. 2 min max. True. 1 1 6. That's not right. We should be R found equals false right now. Oh, we have 2 max A's. We need max. Okay, min A. Mina here. Mina plus equals 1. Found false. Okay, there we go. Now technically, if I just comment all this stuff out, it should work for everything else. Expected is -1 indeed. Still works. This one works. Okay. Hopefully this is it. Hope there's no strange edge cases. Let's figure it out. Oh, nice. Not bad, not bad. Took 33 minutes. 1200 problem. Mostly debugging. Not too logic heavy. Alright. Let's do another one. Rating 1200. You are given an array of n positive integers, a1, a2, an, and a positive integer k. In one operation, you may add either 0 or k to each ai. Choose another array of int integers b1, b2, bn, where each bi is either 0 or k, and the update ai to ai plus bi for 1 to I to n. Note that you can choose different values for each element of the array. Perform at most k operations to make GCD greater than 1. It can be proved that this is always possible. Output the final array after the operations. You do not have to output the operations themselves. Okay, input nk a. Okay, so it's pretty similar to this question, except I need to add nk and then map int map int input dot split. Let me just remove one. one of these. Yeah, that's our inputs. Now, what do we need to do? In one operation, you may add a 0 or k to each AI. Choose another array of integers where each bi is either 0 or k, and update AI to AI plus bi for 1. Okay, let's just look at the test case. In the first test case, the output... Oh, wait, hold on. What are we trying to do? Perform at most k operations to make GCD greater than 1. Okay. For this test case, 8, 10, 10 is valid because GCD is 2. Which is greater than 1. In the array, 2, 7, 1 can be transformed to an at most k operation, 3 operations. At most. So no more than k operations. Let's see what they did. 2, 7, 1. Operation 1. 303. Okay, we can add 0 or k to it, right? Yeah, this is kind of difficult, in my opinion. Because, okay, so the number, like these numbers are 3 times x plus whatever the number is, right? And then we can group the 3's together, or we can... So, we basically... Let me think. We find the number of times we can... Okay, we find a multiple where the GCD is greater than 2. How do we do that, first of all? Like, how do we find 3 numbers where the GCD is greater than or equal to 1? We can multiply them all by the same number. Alright, we can multiply them. Yeah, like 2. Well, if we multiply them all by k, the GCD is by default k, right? In the case of 271, GCD is 3. So we can do 6, 21, and 3. GCD is 3. Now how many operations is this? We go from 4 to 6. We go from 2 to 6. That ain't possible. So 271. How does 271 become 8, 10, 10? GCD is 2. If we added... So get a 2. We didn't even need to operate on 8, to be honest. We really just need these to be even. 10, 4. We can do it in 2 operations. Okay, so it seems like k times 2. You want to try to make it even, and you can make it even with k times 2. So we can have an operations counter. For a in for num in a, if and then okay, we can have an operations counter and a 2 return. For num in a, if num mod 2 equals 0, continue. If else, so okay, so basically, if num mod 2 equals 1, if it's odd, we have to find a number of k to make it even. Oh, odd plus odd is even. Odd plus even is always odd. Which makes it harder than I thought. Where's an even case? 3, 6, 1, 3, 5. Okay. What, 7, 9, 11? That doesn't mean anything to me. 7. They need to be multiples of 3. Right, we have a 6. So we can do 7, 3, 11, 17, 23, 29, 35. That's not a multiple of 3. What is the output for this one? 25, 15, 5. So multiple 5. I guess it's 6 times 24. 6 times 4, 25. 6 times 2, 15. Wait, this is hard. It's like, how do you know which one to use? What does this have in common with 271? We get 3, 3. Now, why couldn't we use 3 or 1 here? We can't use 1. Can we use 3 here? The GCD was 3. Six times. Well, we can't use 3 because 3 is a multiple of 6. So this will never work. 5 is not a multiple of 6. 2 is not a multiple of 3. So we use the lowest multiple, the lowest non-multiple of this, right? This case 4. Let's look at case 4. Why is it not? Control C, Control V. So now we're using what? 3. So okay, 3. Case 3. We use 2. Okay, so I think the trick is we use the lowest number that's not a multiple of this. So I believe in this case, case 2, we should use 5. case 2. Okay, we don't use 5, we use 7 for some goddamn reason. How do we tell? Is there some trick that I'm not considering? Is that 30, 41? No, I don't think adding them does anything for me. How do I know 7 here? And how do I know 3 here? Okay, I have a theory. Well, there's that one case we used 3. We have a case where we use 3. 2, 1, 2, 7, 1. Yeah, here's 3. Okay, say we used 5. Never mind. Yeah, I'm stuck. I don't really see a pattern. Greater than 2. I mean, eventually we can, right? What if we just find the first result? No, it doesn't work. So each number is mx plus b, right? We want to find so we're finding a line. These are lines. With different x values. These are lines where x is the multiple of 3. Okay, and here is the given k. B is this. So it's kx plus b. That's our final number. We're getting GCD kx plus b to be all equal to a number. B is known. X is what we're trying to find. So what if we try all x in a range until it's equal to... Doesn't work, it doesn't work. It's too slow, I think. So what do we output? We want to find x1, x2, x3. Alright. Y is greater than 1. Y is greater than 1. What happens when a number's GCD? When the GCD between two numbers are 1. What does that mean? 2, 7, and 1. Their GCD is 1 by default. 2, 7, and 1. What about like 2, 6, and 1? It's still 1. 6 is 2, 3. 10. 2, 10, and 1 is 2, 5. What about something with that 1? Like 2, 3, and 4. 4 is 2, 2. 10 is 5, 2. 12 is 6, 2. Which is 2, 3. So prime numbers. Is a prime number problem? Well, I did kind of assume that. But like, okay, there's issues with prime numbers, right? 2, sometimes it's impossible to make it a multiple of 2. So you try to make it a multiple of 3. If you can't make it a multiple of 3, you try 5. Do you just try? If you try, you're trying so much. How do you know which prime number to choose? That's another question. Like this case, why 7? Why do we choose 7? Instead of the smallest possible prime number. 2 is impossible because it's odds and evens, okay. 3 is... 3 is possible. This is not the one I was talking about then. This one. 2 is impossible because odds and evens. 3... Is 3 possible? We have 5. 3... 7, 12. 9, 16, 21, 14, 17, 20, 4, oh, it's by 5s, right? So it's 19, 24. They're all multiples of 3. Now, I only get 5Ks. So what can I do? I can do 5, 0, 5, 5, and then 5, 0, 0, 5. Right, I add 10, That's 12. I add 0, that's 9. I add 5, that's 21. I add 10, that's 24. Ooh, am I cooking? If 2 is not possible, we try 3. If 3 is not possible, we try 5. Is there a case where 3 takes too many, but 5 doesn't take too many? Okay, so I think what we can do is our number is just GCD K. The prime we can choose equals 1. And this is the smallest possible number we can use to do 1. Okay, 5. Because we can't use 1. Starting from 2. So it'd be 2. Like if here's 5, we try 2. That would be 1. Wait, can I do 2 for this? I can't do 2 for this. Right? Bro, say that. I do 2. We add even, odd, even, odd. So I can do 2 for this actually, I think. Can I? If I do 2, I do 2, 14, 16. Whoa, 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 yes I can. I'm delusional. Odd, odd. Like even, always even. Odd, odd, always even. Odd, even, always odd. Odd, odd, always even. So, okay, so what if it's like 4 or something? It's 4 and 3. Right, what if it's 6? It's 6 and... not 2, not 3, not 4. 6 and 5. Was there one that tried 6 that I can test this on? This one. 1, 3, 5. So we use 5. And we can make them all multiples of 5. Right. This becomes 15. This becomes 6, 3, 4, 25. That works. I think that's the way to go. So x equals GCD math. Okay, I need to import math. Okay, I need a seethe. What is our upper bound, though? Well, since we're using GCD, we don't actually need a seethe, right? We can technically plug in non-primes, even though we know they can be skipped. We can actually just do something like okay, x equals 2 for while math.gcd k x x plus equals 1. Let's check if this works. Okay, 1. It should print out 2. K is 3. Or did I use it for this? Use 2. Oh, wait. I missed the logic here. Okay. All 2s, that's not right. There we go. Now that I got that, num in A, wait. On X equals 0. What the frick? Now it's running forever. Great. Okay, what did I fuck up on? For num in A, so 2, counter equals 0. Okay. Times counter. Okay, counter shouldn't equal 0. Counter should equal 1 by default. While k times, so while 3 times 1, no, it should be 0 by default. Plus 3 times 1 plus 2 mod 2. Let's print stuff. Oh my god. At least print some stuff for me. Okay, if you aren't gonna do it, make the command line. 0. Putting out our appending counter, which isn't right in the first place. The second one never makes it, which isn't right either. Plus 2. So k times, we have to append this. Now we have 7. K is 3 times 0 plus 7 mod 2 does not equal 0, so counter plus 1. K times 2, k times 1, which is 3, plus 7 is 10 mod 2 equals 0, so this stops. Right? Zero, 2. Why are we getting 2? Do 7 mod 2. Huh? Oh. 0 half. So we append 2. 1. Why? K is 3. Counter is 0. Oh, parentheses. Basic math stuff. 2, 10, 4. Works for me. Second case, 5. We use 2. 14, 16, 14. Works for me. Third case, 1, 2, 3, 4, 1. So we can do 2. 2, 2, 4, 4. Works for me. This case, 2, we can do 3. 2, 5, 6, 7, 8, 9. This case 1, 2, 3, case 4. So 3, right? Which I'll use 3. 9, 6, 9. 8, 9, 10, 11, wait, 12, wait, which are these 3? 8, 9, 10, 11, 12, 9. Now case 2. What's the answer to this one? That passes. Wait, what's the limit? At most k operations. We can do 2, 0. Wait, this is a 7. Okay, never mind then. That works. Next. Uh, 2, 10. 2, 3 works for me. So 1727. Okay, yeah, that works. Now this case. 2, 3. I don't know, I'm just gonna let it be. I think this works. I think it works. Let's try it. It works. Holy shit. Bro, that was a brain teaser of a problem. How long did it take me though? The first about an hour. It's not bad. I like that question. Okay, if y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. Bye.